All right, hello. I just wanted to do another discrete probability distribution problem for you because I know some of this is a little bit confusing. So I wanted to just show, looking at problem 2 here, we have a discrete random variable x, only 0 through 5, integer values, and there's the table, and they don't tell us what the probabilities are. They just tell us A's and B's. We are given that the probability that x is greater than 1 equals 2 times the probability that x is less than or equal to 2. So what that means is when we look at probability x being greater than or equal to 1, that's going to be a plus 2a plus b, because I'm adding up the probabilities that are at 1 or greater. Then 2 times the probability that x is less than or equal to 2 is going to look like this. 2 times the x is less than or equal to 2 would be a plus a plus a. And that gives me on the left side, I have 4a plus b, and on the right side I have 6a. Subtracting 4a tells me that b is equal to 2a. So let's just cross off b in our table and replace it with 2a. Now we also know that it's a probability distribution, so if you add up all of the probabilities, it needs to equal 1. So let's count up how many we have. We have 1, 2, 3, 4, 5, 6, 7. So 7a equals 1, implying that a equals 1/7, and also implying that b, because it's 2a, is 2/7. To double check that that really adds up, 1, 2, 3, 4, 5, 6, 7 seems to be good. Now the expected value of x and the expected value of x squared, let's just switch to another color. The expected value of x is just 0 times the probability of a plus 1 times a plus 2 times a plus 3 times 2a plus 4 times 2a. And so we just get a plus 2a plus 6a plus 8a, and that ends up being 1, 2, 3, 9, 17a, which is 17 over 7. Same sort of idea when you're doing the probability of x squared. You just square the x value and then multiply it by a. So it's still just 1a, but now it's 2 squared is 4a, 3 squared is 9, times 2a is 18a, 4 squared is 16, times 2a is 32a. So what does that make? 55a. So 55 sevenths. And the variance, then, you get the variance by doing, let's switch colors, variance. You can recalculate it all, but there's a great formula, which is it's just the expectation of x squared minus the expectation of x squared. Sometimes you'll see that written as mu squared. And so here we have all the numbers we need. We have 55 sevenths minus 17 sevenths squared. Of course, you can get the exact fraction answer here, but a lot of these probability problems, you'll have access to a calculator, and so might as well just type that thing in there. And it turns out that our variance is approximately equal to 1.959. And there you go. There's a little bit more discrete probability for you.